Hello and welcome to time series forecasting. In this video I'm going to show you an example of how to use various measures that I talked about in my previous videos to select predictors in a regression model. So what I'm going to do here is I'm going to regress two models here. One will regress consumption on 4 variables and the other will regress consumption on income only. And I'm going to save one model as multiple regression and the other as simple regression. And in the next step I'm going to pass a multiple regression into this function CV and get the 5 measures that I talked about earlier, and I'm going to do the same thing with the simple regression. Now we can either use cross-validation, a Geiger information criterion, Geiger information criterion corrected, Bayesian information criterion, or adjusted R-squared. And based on any of these, it seems that the multiple linear regression model is the best model here. Most of the times we will be using cross-validation because cross-validation, as I discussed previously, it gives us more accurate results that how our model will perform on unseen observations. Based on cross-validation, when all those 4 variables are in the model, the predictability of our consumption variable is much better as compared with the predictability of consumption with income as a predictor alone. So in this case, our multiple linear regression model is performing better as compared with the simple linear regression model, and hence we should be including production, unemployment and savings in the model as well. So for this example, what we can do is we can regress all possible models, which will be 2 raised to the power of the number of predictors, and we have 4 predictors here, so we'll have 14 potential models. And here are the 14 possible models, and our model 1 contains all the 4 variables in the model, and then we have experimented with the different combinations of the models that we can run, and our final model does not contain any of these 4 variables in the model. So looking at the results, seems like if all of those 4 variables are in the model, our CV is 0.116. And if we draw production from the model, seems that our CV is unchanged. That is, whether we include production in the regression model or not, it has no effect on the cross-validation measure. It is still the same. So if we are using cross-validation, then we should probably pick model 2, because parsimonious models are always better than models with more variables. Hence, if 2 models are giving you identical results, pick the model with the minimum number of predictors. Pick a parsimonious model as compared with the model with more variables. So in the next video, I'm going to talk about various ways of selecting these predictors based on various methods. And essentially this was just one example where we were able to regress all combinations of all of these 4 predictors. And we'll see that sometimes it is not possible. So we have to come up with a strategy to handle that situation. Alright, I'll see you in the next video. Bye-bye.